The diagram above shows a sketch of the curve with the equation y equals f of x, with x being a real number. The curve has a turning point at A, which is the coordinate 3 minus 4, and also passes through the point 0,5. Part A. Write down the coordinates of the point to which A is transformed on the curve with the equation y is the modulus of f of x. So the modulus sign here is going to make the y coordinate become positive. So originally the y coordinate of the turning point was minus 4, so this is now going to become a plus 4. The x coordinate is going to be unaffected. The x coordinate is going to stay at 3, and the y coordinate gets turned from minus 4 into plus 4. Part II. We've got two things here. We've got the half x on the inside there, and then we've got the 2 f of x on the outside. So first of all, the half on the inside, because that's on the inside of the function, that's going to affect the x coordinates. And we're going to do the opposite. So instead of multiplying by a half, we're going to divide by a half, and therefore that's the same thing as multiplying the x coordinate by 2. So the original x coordinate of point A was 3. We're going to multiply that by 2 and get 6. The 2 on the outside of the function is going to affect the y coordinate, and we're going to do what we would usually do there. There's no opposite when it comes to the y coordinates. So we're just going to multiply the y coordinate by 2. So the minus 4 becomes minus 8. Part B. Sketch the curve with the equation y equals the function of the modulus of x. On your sketch, show the coordinates of all turning points and the coordinates of the point at which the curve crosses the y-axis. So the modulus on the inside here affects the x coordinates. So when x is positive, the modulus has no effect at all. So this part of the graph where the x is modulus is positive, all the x values here, all the x values there are positive. So that part of the graph is going to stay exactly as it is. It's this part of the graph over here where x was previously negative. That's the bit that's going to change. That's the bit that's not going to exist at all anymore, because the modulus turns those x values to be positive, so that it will be exactly the same as it was on the positive side of the graph. So it's going to look like this. It's going to be a reflection, if you like, in the y-axis. And we will have another turning point here, which would be the coordinate minus 3, minus 4. And this is the point 5 on the y-axis. Let me just draw the rest of the x-axis in here. And that's it. So when you have a modulus x on the inside there like that, what that means is you rub out, you ignore the negative part of the graph. So I'm ignoring this part of the graph here. And then I just copy the positive part of the graph over. The curve with the equation y equals f of x is a translation of the curve with the equation y equals x squared. So this is saying that my f of x, let me get this back, the original f of x. So this f of x here, this is a translation of the graph that would usually be y equals x squared, which we know looks like this normally. So this is my x squared graph. Now we can see that this has been translated 3 squares in the positive x direction and 4 squares in the negative y direction. We know it's 3 and minus 4 because of the coordinate there. So how I would represent that then, if the original function, let's just call the original function f of x for now, the translation of 3 in the positive x direction would be represented as f of x minus 3. And then the translation of minus 4 in the y direction would be represented like that. Right, the actual specific function we're talking about here is the x squared function, remember? That's what's been translated. So instead of writing f, let me write squared. And therefore this is my f of x function. You could expand that out if you wished, but it doesn't tell me how I need to write this answer, so I'm going to leave it like that. That is the blue function there, the f of x function. And then finally, part D, explain why the function f does not have an inverse. Well, the function is a many-to-one function. F is a many-to-one function. Let me just remind you what I mean by that. That means that there are many values of x that I substitute in that give me one value of y. For example, if I substitute this x value in, then I'm going to get this y value out. But also, if I substituted this x value in, I would get the same y value out. So it is many, as in 2 to 1, many to 1. Now the problem with that is if I did an inverse of that, the inverse would flip the domain and the range around. So the many to 1 would become a 1 to many, which is not allowed. You can't have a 1 to many function. So a many to 1 function, the function f is a many to 1 function, so the inverse function will not exist.